All right, in our previous class, we looked at how to solve for future value of a regular and compound interest, future value of a regular compound interest. But let's see other cases. For example, let's see semi-annually. Now, let's see a problem and how to solve it. Now, let me give you a formula on how to solve for the future value of a compound interest compounded semi-annually. So, you are looking at compounded semi-annually, for example. The formula is A equals to P bracket open 1 plus R over M bracket close N times M. So this is more of a complex problem, but it's still simple. It's a simple problem nonetheless. So we are going to look at a problem, a solution. All right, already in our former class or a former lecture, you should be able to understand what A stands for, what P stands for, what R stands for, and what N stands for. So the difference is we added M and M into the equation. So let's get to know what the M in the equation stands for. Now the M means periodic compound. So it means how many times a specific amount is compounded. So how many times a specific amount is compounded, that's what it means. So let's see a problem. So John obtained a loan from a bank for, let's say, $2,000 with an interest rate of 2.5% to repay in 3 years' time. Now the question is, what is the future value of the loan if compounded semi-annually? Okay. All right, let's go again to the question. All right. John obtained a loan from a bank for $2,000. John obtained a loan from the bank for $2,000 with an interest rate of 2.5% to repay in 3 years' time. With an interest rate of 2.5% to repay in 3 years' time. Now, what is the future value of the loan if compounded semi-annually? So the question is, if the loan is compounded semi-annually, what is the future value of the loan? So we're going to restate the formula. The formula is a guide for us. The formula is AP bracket 1 plus arrow over M bracket close. There's a big bracket close, and times M. That's the formula for semi-annual compound. All right, now let's go on. So your A is, now your P is the present value of the loan, and according to the equation, the present value of the loan is $2,000. So $2,000. Now the rule is, first solve for the bracket. Solve for the bracket is the rule. Let's solve for the bracket. Now what do we have? We have 1 plus, now the R there is the rate, and the rate is 2.5%. And what I told you before is that you must convert the 2.5% to decimal fraction. Now let me practically show you how to do that. So to do that, this is our calculator. We'll just say 2.5 divided by 100. Now what do we have? We have 0.025. So go back to it. We have 0.0025. Mind you, there's a bracket here. Divided. Now M. Now anytime you hear semi-annually, all right, based on what we are asked to do, ly is 2. Is twice in a year. Anytime semi-annually means twice in a year. So wherever we see M, we'll substitute or replace M with 2. We are going to replace M with 2. Beautiful. Now the next stage to do is to solve for this, to divide this and divide this. Alright, to solve for this, we're going to go back to our calculator. 0.025 divided by 2. So when you divide 0.025 by 2, you have 0.0125. So at this point, we have 1 plus 0.0125. Beautiful. So at this point, we're going to solve for this. Now, what do we do at this point? We're going to plus. We're going to say 1 plus 0.0125. So 1 plus 0.0125 is 1.0125. Now let's go back to the power. Initially, we ignore the power, so we can solve for the bracket first. So now we're going to revisit the power. Now what is in the power? N and M. Now the N is the number of years, M is the periodic compound. Now according to our question, let's look back at our question. And our question number of years is 3 years. Alright, 3 years. And it's compounded, the number of times it's compounded is semi-annually. And I remember telling you semi-annually means 2 times. So we are just going to multiply 3 years by 2 times. So we would say 3 times 2. All right, at this point we have, we'll go 1 bracket 0.0125 raised to the power of 6. All right, that's fine, it's power of 6. Now we are going to solve for this. We're going to get 1.0125, same thing as what we have here, raised to the power of what? 6. Now let's visit our calculator. So we have 1.0125 raised to the power of 6. 1.0125 raised to the power of 6. What do we have? We have 1.077. Now I'm going to reduce it to 2 decimal points, so I will approximate it. Alright, so if I approximate, I'll have 1.08. So I have 1.08. Alright, that is it. 1.08. Okay, so this value I have here is called discounted factor. I told you the easiest way is for us to solve for the bracket, then we apply the power, and then we'll get our discounted factor. So our discounted factor for the 6 years is 1.08. So we're going to multiply our discounted factor by the present value. Present value, what is the present value? This is the present value. So let's multiply it. Let's multiply this value, this factor here, that we are going to use to discount it. Now, we are not saying we are discounting. This is actually called the compounding factor, because for principal it's called discounted factor, but for future value it's called compounding factor. So our compounding factor is this. All right, these are compounding factors. So refer back to the other lecture, this is our compounding factor. All right, so let's get these are compounding factors. So we'll multiply our compounding factor by our present value to get the future value. So $2,000 times 1.08. So let's multiply them. So what do we have? 2,160. $2,160. Finish. Please subscribe for other ones.